Alright, welcome back. Today we're going to talk about data structures and we're going to specifically talk about sets. So in today's lessons we're going to create a set, we're going to add and remove elements, and we're going to go over the set operations. So we're going to go over the union, the intersection, the difference, the semantic differences, the subset, and the supersets. Then we're going to convert a list to a set and back again to a list. And then we'll do a simple loop. And as a bonus, we're going to do Venn diagrams.
I love Venn diagrams.
All right, moving on. Okay, so we're going to go over and create a set now. And basically what a set is just an unordered collection of unique elements. So there's no really particular orders in there. So what we're going to end up doing is we have the presidents, and we're going to do a curly brackets. And anything inside curly brackets is going to be a set. So we can do Trump, because we're doing presidents. And then before him is Biden. And then we had Obama. And then we had a Bush. Okay? And if I print this by hitting Shift Enter, then I'm going to print the presidents out. And I can see that they're in the set: Obama, Biden, Trump, and Bush. And you're like, well, wait a minute. That's not the order that I put them in. And that's correct, because remember, it's an unordered collection of unique elements. So when I put in the information, it just puts it in anywhere that I want to put it in. Okay? So it's unordered, so it doesn't really matter. Okay? Now, if you're up here looking at the presidents and said, well, wait a minute, like Trump had a term between Biden and Obama as well. Well, the reason I didn't put that in there is because the list, or the set won't take duplicates. So if I put Trump in here, even though that I have Trump in there, so Trump, Biden, Trump, Obama, and Bush, and I run this, it's only going to say Obama, Biden, Trump, and Bush, because it removes all elements. So they have to be unique in there, so it doesn't take duplicates. Even though I said to have the duplicates in my set, it's not going to honor that, and it's going to remove all duplicates when I do my set. Okay? And that's pretty much how you create a set. Okay, so how do I add and remove elements? Okay, so if I hit Shift Enter, I can see my presidents down here again. And remember, the sets are unordered. So if I do president dot add, and let's add Clinton in here. So we'll add Clinton, and if I run this, I have Clinton right here. Okay, so that's right. So let's say that I want to add more than one. Well, I can do that by doing presidents, and then I do the update command. And then this time what I'm going to do is I'm going to make a list. And that list is going to include Reagan. And it's also going to include Carter. And if I run this, now you see Reagan's in front, Carter's over here, because again, sets are unordered. Okay? So that's pretty much adding the elements in there. Now, if I want to remove the elements, there's different things I can do, right? So if I go down here to remove elements, I can say, let's go presidents dot remove, and then I'm going to remove Clinton, okay? And I hit enter, and notice Clinton is gone, okay? And then the problem with remove is, let's say I want to try to remove Clinton again, it's going to error out. So I hit Shift Enter, and see it's error because there's no president named Clinton because I already removed him. Okay? So let's remove a different president, and let's do this in a different way. Okay? Let's remove Carter. This time I'm going to do discard. Okay? And I'm going to discard Carter. And if I run this, you notice Carter is no longer in my data set. Okay? Now, to show you this, I can run this again, and I hit Shift Enter, and it doesn't error out. So I think that, using discard in lieu of remove is always probably a better way to go. Now, the next thing we can do is to remove a random president. We could do this by using the pop command. So we'll just do pop, and we're just gonna pop out the president. So we got Reagan, Obama, Trump, Bush, and Biden left. So if I run this, pops out Reagan, and it's always gonna pop out this first element. So if I run this again, I have like Trump, Bush, and Biden. Okay, and the next thing we can do, let's say that we're just done and we don't want this in there, we just want to start over. We can do clear and run this, and it just clears the set. So president's still set, it's just cleared out. And adding and removing elements is simple as that. Okay, so the next thing we're going to go over are set operations. So we have A and B already in sets. I got 1, 2, 3, 4, and then I got 3, 4, 5, 6. And if I run this, you'll see that I have my sets 1, 2, 3, 4, and 3, 4, 5, 6 respectively. Okay? So let's go down here and look at the union. Okay, so basically like a union combines all elements from two sets. So if we have the set of A and B, and I do A union B, then I'll have 1, 2, 3, 4, 5, and 6. So how do I do that? Okay, well, it's actually pretty simple. I can do print, and then I'm going to do A dot union, and then I'm going to do B. Okay, and I'm going to run that. And I have 1, 2, 3, 4, 5, 6. So doing a union, pretty straightforward. So now, what I could do, I could do print, and as a shortcut, do like this A, and then do the pipe, and then do the B, and I can run this, and I get the same results, 1, 2, 3, 4, 5, 6. So you can be explicit and use union, or you can take the shortcut and use the pipe. Okay? So the next thing we have are intersections. So intersections are elements common to both sets. So we have our sets of A and we have our set of B up here, and then we have A intersection B, and that should give us 3 and 4. Because if you notice, 3 and 4 is in the A, and 3 and 4 is in the B. Okay? So how do we do that? Well, we can do the print command again, A dot intersection, and then we do a B, and we just run this command, and we get the 3 and 4. And you're like, wait a minute, is there a shortcut? Yes, there is. I can do print A, and I can do B. Okay? And I run that, and that gives me my 3 and 4. Okay? So intersections are pretty straightforward. Now, let's go down and look at the differences. Okay, so difference is elements in one set, but not in the other. So we got 1, 2, 3, and 4, and we got 3, 4, 5, and 6. So basically, what's in A that's not in B? So if I look at the difference is 1, 2, that's the difference. Because if I look at A, right, 3 and 4 are in B, but 1 and 2 are not. Okay? So I can really come down here and just do print, and then I can do the difference. Okay, dot, let's see, difference, B. Okay, and I forgot to put my A dot in front of this. So print A dot difference B. And if I run this, I misspelled difference. There we go. So you got to spell it correctly. So I got the print A dot difference B, and I get the 1 and 2's respective. Now, if you think about the shortcut, we kind of show the shortcut up here, A minus B. So we can just do the print, A minus B, and then I get the 1, comma 2 like I'm supposed to. Okay? Now, we could do this like backwards. If I want to do like B and A, and I can run this, I get 5 and 6, right? Because if I look at this, 5 and 6 is over here, but not in the set A, but 3 and 4 are. So that's why that would be 5 and 6. Okay? So if I go down here, let's look at these symmetric differences. So those are basically elements that are in either set A or set B, but not in both. Okay? So if I look at 1, 2, 3, 4, and 3, 4, 5, 6, from A and B, and look at that, I notice 1 and 2, okay, are not in set B. But 3 and 4 are common, but 5 or 6 are not. So that's why we would get the 1, 2, and the 5, 6. Okay? So how do we do that? Well, you probably guessed it already. We're going to do the print. And then we're going to end up doing a dot. And I'm just going to copy this up here because I don't want to misspell it. And I'm going to throw it down here and take out the space and put an underscore there. Okay? And then we're going to sit there and do the B. And I'm going to run this. And that's going to get the 1, 2, 5, 6 as expected. Okay? And you're like, man, I don't want to spell that every time. That's long. I'm with you. So the shortcut for that is going to be A, and then we're going to do the caret, and then we're going to do the B, and we're going to run that. And it gives us the exact same results. Okay, so now we're going to go over the subset and the super subset. So basically for a subset are all the elements of A and B. So for example, like 1, 2, and 3, and then 1, 2, and 3, that's true. And then the super subset, does B contain all elements of A? So 1, 2, 3, and then 1, 2, so 1, 2's out of B, and that would equal like over here in A, so that'd be true as well. So here's our numbers, 1, 2, 3, 4, 3, 4, 5, 6. So we're going to check if A is a subset of B. Okay? So how do we do that? Well, I do the print, I do the A is subset of B. And I run that, and it's going to say false. Because A, remember A is 1, 2, 3, 4, and B is 3, 4, 5, 6. So what we're checking for are all the elements of A in B. Okay? Well, they're not, because 3 and 4 is not in there. But if I take this, and let's change my data set here a little bit, and I'm going to do this. I'm just going to say 1 and 2, for example. So check if A is a subset of B. So we have A 1, 2, and B 3, 4, 5, and 6. And it says check if A is a subset of B. Well, I'm going to add a 1 and a 2 to this B set. And run this again. And it's going to be true because A is in fact a subset of B because we have the 1 and 2 there and the 1 and 2 here. Okay? So that's why that's true. So let's go to the super subset. And I'm going to take these data sets again, come down here to the superset, and I'm going to just make sure I'm using the same data set. Okay, so now that I'm back to there, I'm going to do print A dot is superset of B. And I'm going to run this, and it's going to say false. So why is that false? So if I go up here and look again, and we notice that our super subset, does B contains all elements of A? So does it? Well, 1 and 2, it contains the elements of A. Okay, so if I go down here and let's say that we have 1, 2, 3, and 4, well, we're missing 5 and 6 out of A. Okay? So if I put 5 and 6 in here, so we got 3, 4, 5, and 6. I got 3, 4, 5, and 6. So it would be a superset. So if I run that, we're going to do true. So looking at the set operations, it's really as simple as that. Okay, so let's convert a list to a set and then back to a list. Okay, so right here we have our numbers, which is the 1, 2, 2, 3, 3, 3, which are duplicates. And we know sets don't allow duplicates. So I could do unique, I could do numbers equals, and then I want to say I want those into a set, and that set to be numbers. Okay? So basically I'm taking this list and I'm converting it to a set. So when I do that, I can do print, I can do unique numbers, and you can clearly see that I have a set of 1, 2, 3, which are unique now. Now let me convert that set, back to a list. Okay? So now I don't want the set, I want a list. So I can take that unique list, okay, and I can just say I want it to be a list, and we have the unique numbers. Okay? So once I do that, I can do print unique list, and I have it back in a list right there. So this is good if you have a list with a bunch of duplicates in there and you want to quickly remove them. Just change them to a set like we did up here. Then we take that set and then we change it to list, and then we can do list operations on it. So really converting a list to a set and back to a list is really as simple as that. Alright, so the next thing we're going to do is just a simple loop. So we have our set 1, 2, and 3, and 4. And if we want to do a simple loop, very simple, like 4x in A, and then we're just going to print the x. And there we go, just basically a simple loop. Alright, so what we're going to do now, we're going to do a bonus, which is a Venn diagram.
I love Venn diagrams. It's just something about those 3 circles and the analysis about where there is the intersection, right?
Okay, moving on. So since this is a set video and it's not really a visualization video, I'm not really going to go over all the code in the bonus Venn diagrams. I just kind of want to show you what you can do with them. If you guys are interested in a visualization piece, I can do a tutorial on that later. Just let me know in the comments below. But basically what we got here is we're just importing the matplotlib. We're importing the plot and the Venn diagrams where we can actually visualize those. We have our sets up here that we define. We have our color key for our operations. We have our functions to help us plot with the Venn diagrams to include the legend. And we're showing the elements, highlighting the areas. And then basically we're going to create the figure with 8 subplots. And then we're going to do the union, the intersection, the difference, and the semantic differences. Okay? So if I run this by hitting Shift Enter, it will take a second. And then what it's going to do is going to pop up. And what I have here is we have the union, which is A union B, and we notice blue, that's everything, so it's including all my data sets. Over here with the intersection, we have this, and then we have this color like up here, like this pinkish color, and we know the intersections is at 3 and 4. Okay? And if we go down here and see the differences, and the differences in blue, so we got that 1 and 2. And for the semantic differences is that color right there, like a yellowish, so we got that 1 to 2, and we have that 5 and 6. And plotting it to visualize it, really that simple. But again, the point of this video was show you how to use the set, not so much a visualization. But again, if you're interested in that, let me know, and I can create a video for you for that. Okay, so I hope you learned something today about the sets. Please let me know in the comments below if you learned anything. Basically, we created sets, we added, removed the elements, we went over the set operations, showed you how to remove duplicates by converting to a list to a set and back to a list. A simple loop. And again, we showed you a visualization on the Venn diagram in case you wanted to visualize it. If you want to know more about that, you can go to GitLab and you can download the code from there and look at it. Let me know how you plan on using sets, and I'll talk to you next time.